Today we get to look at the applications of some of these trigonometrical ratios. Now we said that the use of trigonometry, sine, cos and tan only applies when we are dealing with right angle triangles. But we can still use the trigonometrical ratios to try and help us find area of a triangle that is not right angled. Today we are going to get to look at one of the applications of trigonometrical ratios. One of these applications is trying to find the area of a non-right angled triangle. This is Kisembo Academy, and thanks for tuning in. The area of this triangle, for example, is a half times base times height. So now, on choosing which base we should use when we are trying to find this area, we can either use this base, we can either use that base, or we can use any side to choose which base. But then remember that the base and the height must be meeting at right angles. So it is the base times the perpendicular height. This perpendicular height must be perpendicular to the base. So here we have chosen this B to be our base, then times our perpendicular height. Now this was not originally in the question because originally this triangle is not right angled. So we try and create our perpendicular base by dropping a perpendicular from point B to come and meet this line. So when you drop that perpendicular like that, it means that we have created the height that is perpendicular to the base, but we do not know the value of that height. So for us to be able to get the value of that height means we are supposed to use trigonometry to be able to get that value of h, because first of all, if you look at when we create that height, we create a right angle triangle of that form. And when we create a right angle triangle of that form, this is our value h, this is a, and this is angle c. It means we can find the value of h using trigonometry. So for us to be able to get this value of h using trigonometry, if we find the sine of c, sine of c is going to be equal to, sine is equal to opposite, which is h, over hypotenuse, which is a. So it means when we make h the subject of the formula which we are interested in, our value of h, the height, is going to be equal to a times the sine of c. So after getting our value of h using trigonometry, then we can come here and substitute, and we say it's going to be a half times base, which is b, times the perpendicular height, and the perpendicular height here is a sine c. So it becomes times a sine c. So it means our formula for finding area is going to be a half times ab sine c. And this we can use when we are trying to find the area of a triangle that is not right angled, but we get the height with the help of trigonometrical ratios. Now we say that we can choose on any base. We can use this line b to be our base, we can choose this line c to be our base, we can use this line a to be our base. Now if we are to use line b to be our base, it means that the perpendicular height will be dropped from this point downwards. What if we used a as our base? Of course, if we used a as our base, it means the perpendicular height will be dropped from this point there. Likewise, if we used c as our base, it would mean that perpendicular height will be dropped from point c. Now let's try and see what if we used c as our base. It would mean that we're supposed to drop the perpendicular height from point c up here, like this. So it means that this is supposed to be our value of h, like in the following picture. Here we have used our value of c as our base, so it means this is going to become our height. So if we want to find the area of this triangle, it means it's still going to be as before. It's going to be a half times our base. Our base is c, times our perpendicular height, which we do not know, h. Now we need to find the value of h using trigonometrical ratios. Maybe if I am to flip this way, you find that we have a right angle triangle here, like that. So for us to be, we have an angle here, angle A. Let me redraw this. So our value of our C, if you look at it this way, this is the right angle triangle I'm trying to extrapolate. This is angle A, then the hypotenuse is B. So we have angle A here, hypotenuse is B, then we have our height H, which is that one. So for us to get this value of H, the height, we are still going to use trigonometry to get this H, because we do not know it. So if we use the sine of that angle, sine of A is going to be equal to opposite over hypotenuse. The opposite is the H we are looking for over the hypotenuse, which is the B. And we find that our value of H is going to be B sine of A. So substituting for this here, it means it's going to be the area of this triangle can still be gotten by saying a half times C, which is the base, times H, which is B sine A. We can rearrange this by calling it a half times BC sine of A. So this shows us that by using trigonometrical identities, or by using the trig ratios, it can help us to get the height of a triangle so that we are able to calculate its area. Let's do a few examples to illustrate this. Our first example is a triangle that is not right angled, and we are required to find the area. Now, finding the area of this triangle PQR, we simply choose a base. We can choose this base, we can choose that base, but let's choose PR as our base. And if we are to choose PR as our base, it means our perpendicular height should drop in like that, our perpendicular height H. So we know that our area A is going to be a half times base times perpendicular height. That's going to be a half times our base, which is 21 centimeters, times our perpendicular height. Now this is our perpendicular height we have just created. We do not know what it is. So we are supposed to find that perpendicular height using trigonometry. If this is our value of H, which we've gotten there, and this is our angle 23, this is our hypotenuse. We do not know the hypotenuse, so let's ignore this. Let's consider this right angle triangle this side. So the right angle triangle that side is having here 21 degrees. We have 12 as our hypotenuse, and we still want that value of H. So let's consider this right angle triangle. Since this one is missing some information, we won't be able to get our value of H. So to get this value of H from here, if we are to get the sine of 21, we know that sine of 21 is going to be equal to opposite, which is the H we are looking for, over hypotenuse, which is 12. So it means our value of H there is 12 sine of 21. So if we come and substitute this value of H here, it's going to be a half times the base, which is 21, times our value of H, which we've gotten as 12, times the sine of 21. And when we compute that, our answer will be 45.154 centimeters squared. That is the area of PQR. Next example. Our next example is pretty much the same. We are required to find the area of that triangle. It's an equilateral triangle because all its sides are the same. So if we are to find this area of this triangle, it's simply going to be a half times base times height. Let's choose a base like this one. So it means our perpendicular height, we shall formulate it. This is our perpendicular height. So we have our base as 2 centimeters. We need to get the height. So the height, we get it using trigonometry. If that is the value of H, and this here is 2 centimeters, and this is 60, still if we use the sine of 60, the sine of the angle 60 is going to be equal to opposite, which is the height we are looking for, over hypotenuse, which is 2. So it means our value of H is going to be 2 sine 60. So we substitute it here. So it means our area here is going to be a half times our base, which is 2 centimeters, times our height, which we've gotten here as 2 sine of 60. And when we compute that, we end up with our answer as 1.73 centimeters squared. And that is our answer. Now there is another way we can get this height as far as this is concerned. This being an equilateral triangle, all its sides are equal. It means that this perpendicular height we are dropping from this point to here is going to divide this base into 2. So if it divides this base into 2, it means if the distance from here to here is 2 centimeters, then this from here to here is 1 centimeter. This is also just 1 centimeter. And if this here is just 1 centimeter, then it means we can still get the height using Pythagoras theorem. But since we are dealing with trigonometry as a topic, then that's why I'm only going to interest myself with using trigonometric ratios to get the value of height. Otherwise, this only works if it is an equilateral triangle. Please remember to share this video on other video sharing platforms and also subscribe and hit that like button. Thanks for watching. This is Arnold Rangakuramya for Kisembo Academy.